So we were talking about this a little while back, but coming back to it, just to explicitly mention this, in regard to quantum hardware, how is it done? Like we did talk about the breakdown of uh, frameworks and algorithms and the software aspect, but to give us step by step description of quantum hardware, its assembly, how is it built?
Okay, so I'm not a complete expert in these things in quantum hardware, I would say, but as per my knowledge, so there are like various platforms in which a qubit could be realized upon. So one of the famous ones is a transmon. Then there are photonic trapped ion based quantum systems. Then there is something by D-Wave. I'm not sure if I'm pronouncing it correct. It's called fluxions, which is also a similar kind of and system on which it's also a superconducting system in which, so basically when we come to building a quantum hardware, it's like the first layer is what we will need is a qubit, an actual realization of a qubit. So we could have, so one could say a qubit is nothing but an oscillating particle which has a different which follows, which should behave like an atom. So what right now we have are the artificial atoms which behave like so it could have a different, it should have a ground state and excited state. So there are like there is something known as, there are six criteria of building such a quantum hardware known as the Da Vinci criterias. I'm not able to recollect all of them in my mind right now, but so on this criteria you could actually state how a qubit is built. So the next phase is comes is the communication of these qubits, of how you could operate them. And so there are various cavities and various uh, uh, I would say very various ways of interacting it. You could have like a resonators and stuff where it could actually help in measurement, which is actually turns in a transmon based qubits. So so this kind of a thing is there. Then the refrigerator which you see in a quantum system is actually just to have a superconducting level, but then the whole wirings are nothing but the microwaves, the electromagnetic waves which are communicating with this kind of hardwares. So that is the thing. So you have a classical system which will produce instruction in terms of pulses are nothing but this microwaves, the electromagnetic waves, which goes and interacts with the system which we have created, which is the qubit, and does our operations, and then give back a result, which is again in terms of the microwaves, and we again uh, read it, and then we get our values. So that's like a very broad way of describing how the quantum hardware works, but it completely depends on various kinds of hardware. There is much into all of this. There is a lot of physics into all of this. So yeah, I'm not getting into deep into that, but yeah, this is exactly how it works. It's like you have a control unit. The control unit just talks with the quantum processors. The quantum processors use an output back to the control unit. The control unit then talks with a classical computer. So this is a simple way of how the quantum hardware process works out. It's same kind of like what our classical systems have worked. They also have a control unit. They have CPUs, GPUs, and stuff. So yeah.
How